Hi everyone, we're going to solve some quadratics here by factoring even though a is not equal to 1. These are our trickiest examples to factor. Looking at the first one here, the shortcut to always start with is to find a GCF. So what goes into all of these pieces, the greatest common factor, we're going to factor that out to make this quadratic a lot easier to work with. They're all even, so I'm going to factor out a 2 and then write the rest in these brackets here. You could use parentheses or brackets, doesn't really matter. And that way we have a lot easier trinomial to work with. Smaller numbers are always a little bit easier to work with. Now from here we've got our a, our b, and our c, and we're going to use this method to factor. We're going to do the a times c, so 3 times 14, which is 42. And we're going to see what adds to b but multiplies to 42. So that's going to be 6 and 7. Okay, 6 times 7 is 42, and 6 plus 7 is 13. That's how we're going to kind of split this up. So we're going to take the 3x squared the same, but we're going to write the 13x as 6x plus 7x, and keep everything else the same. All we've changed is this so far, but really it's not different, it just looks different. Now we're going to factor the GCF out of each half. So we're going to do 3x out front times x plus 2. And then for this one, it's going to be a 7 times x plus 2, which is good. The key is you want to make sure that these two always match. Otherwise, it's not going to be factored. Now, the 7 is really a positive 7, so put the plus on there. Bring down the square brackets and the 2 out front and the equal 0. Now we've got to actually rewrite this inside part as a product of two binomials. So you'll see here the x plus 2 is in both of them. And the 3x plus 7 is actually the second binomial, because what's really happening here, if you were to distribute this into the whole binomial, it would look like the previous step. So we're essentially just undoing that distributing. The 2 out front is still there and equal to 0. Now we can use what we call the zero product property. That says that if a times b is 0, then a is 0 or b is 0. In this case, we actually have 3 things that are multiplying to 0, so one of them has to be 0. But 2 cannot be 0. No matter how hard 2 tries, 2 cannot be 0. So we're going to kind of ignore that when we go to the next step here, because it just can't be 0. But x plus 2 could be 0, or 3x plus 7 could be 0. So these will give us our two options. So we get x equals negative 2, or 3x equals negative 7, which means x is negative 7/3. So our two options are negative 2 and negative 7/3. Okay, over here we got kind of different numbers, just bigger numbers here for the a, which is a little bit trickier. And there's no GCF, so we're going to do the a times c. 12 times negative 2 is negative 24. What multiplies to negative 24 and adds to positive 5, the b. Got to add to b. That's going to be 8 and 3 because they're 5 apart, but 8 has to be positive in order to get to a positive 5 when we add them together. So it's going to be 12x squared plus 8x minus 3x minus 2 equals 0. Then again, factor out the GCF of each half. This would be 4x times 3x plus 2. I got to have 3x plus 2 over here, so I'm going to put that there. And now I have negatives in here that I don't have in the bottom, which means this has got to be a negative 1 in order to make these two match, which I need. Then we've got 4x minus 1 times 3x plus 2 as our two factors by just combining 4x minus 1. And then the 3x plus 2 is in both of them. So that's got to be the other factor. Again, the zero product property says one of these has to be 0. So set them both equal to 0 to find our possible values of x. We do our two little steps here, and we get x is 1/4, or x is negative 2/3. Those are our two options here for x. We say or because x can't be two numbers at the same time, but it can be either of those numbers. Okay, moving on to this one, looks kind of crazy. We got to get it equal to 0, so we're going to move things around here to get it equal to 0. You can kind of do things in a different order, but I'm going to move the negative pieces. That way I can get all positives. I'm going to move these over here. I'm going to move these, 38x over here, and then move the 12. Plus 12, plus 12. That way the whole left side is gone. That means it's 0. You get 8x squared minus 28x plus 12. I see another GCF here. They're all multiples of 4. So So we're going to take that out front to make it easier to work with. Now we've got smaller numbers for a, b, and c. So for a times c, that would be 2 times 6, which is 12. Oh, hold on. That's a 3. Let's try again. Should be 6. Okay, what multiplies to 6 and adds to 7? Well, it got to be 1 and 6, but it's -7, so they're both negative. So we get 0 equals 4 times 2x squared minus 1x minus 6x plus 3. Again, we're going to factor out what's the GCF out of each half. So we're going to do x times 2x minus 1. And then for this one, we got to have 2x minus 1 again. So we're going to do a 3, but actually a -3 in order to make that the same. And then again, we combine the x and the -3, the 2x minus 1, bring down the 4, bring down the equal 0. Now we've got a product of 0. We set each one equal to 0 except for the 4, because 4 can't be 0. No matter how hard it tries, 4 just cannot be 0. But these things can be if x is 3 or 2x is 1, which means that x is 1/2. Those are our two options, 1/2 and 3. Ooh, that's a weird 3. Let's try again. There we go. Okay, one more example here, number 4. So again, we've got negative x squareds, which is not great. Let's move everything over. So plus 20x squared, plus 82x, plus 72, plus 72, plus 82x, plus 20x squared. Can do the same thing on both sides. Gone, gone, gone. So 0 equals 80 plus 82x plus 20x squared. This is not in standard form yet. Let's get it in standard form. Highest powers first, lower power next, and the smallest power at the end. Okay, a lot of big numbers here. Let's look for a GCF. It's like they're all even. So 2 times 10x squared plus 41x plus 40. Okay, now we're going to do our a times c. And what adds to b? So AC would be 400. It's usually pretty tricky when we got these big numbers in order to find the factors that'll work. So if you want to go through and write down all the factors, it'll eventually get you there. But the one we want in order to add to 41 is going to be 25 and 16, which will take a long time to get to, but that is the one we need for this. So we get 0 equal to 2 times 10x squared plus 25x plus 16x plus 40. Do our GCF of each part. This would be 5x times 2x plus 5. We're hoping this is also 2x plus 5, and it is when you factor out an 8. Make sure it's positive. Bring down the 2 and this equals 0. So this is 5x plus 8 times 2x plus 5, all times 2 equal to 0. And again, use your 0 product property here. Set each part equal to 0, except for the 2. 2 can't be 0. But 5x plus 8 could be 0, or 2x plus 5 could be 0. Solve each one for x. So minus 8. 5x is -8, which means that x is -8/5. Or 2x is -5, which means that x is -5/2. There's our two options. So -5/2 and -8/5 in either order is always totally fine. That's how we do it. That's how we solve quadratics, by factoring. Even when we got these tricky trinomials where a is not 1, first off get it equal to 0, then do a times c, split the b term up into those two pieces, do your factoring of each half, the GCF, and then you'll get it into that nice two binomials, set them equal to 0, and solve from there. That's how